Hello everyone, this is Ravis Key doing a quick and dirty percent composition hydrate empirical molecular formula for the week of April 6th through April 10th. We'll jump right in for a quick problem on percent composition. Calculate the percent iron and iron 3 sulfate. First thing we need is this formula. Iron with a +3 charge would cross over with sulfate's charge, so that your final formula would be Fe2SO4 3. Okay, now that we've got that charge, to find percent composition, you need to find the total mass and put what you're looking for on top. So here's how we find those two items. First of all, for total mass, I like to do it first. It's just a lot easier. We're going to say 2 times 56. Now you're wondering where these numbers are coming from. The formula tells you there's 2, and that's where that 2 came from. The 56 came from the periodic table. We're going to try to round as close as we can. So we're going to add that to 3 times 32. Again, the 3 on the outside of the parentheses tells you there's 3 S's, and each S is 32. Plus 12 times 16. Now, to make my math friends happy, we'll put all that in a bracket. And then what you looking for? How much iron? So we had how much iron in that? 2 times 56. Okay, and we're going to multiply all of this times 100%. So when you do the math, you'll get 112 over 400 times 100%, which gives you 28% iron. That was pretty easy. Well, very similar to percent composition, you have something called hydrates. A hydrate just means it has water in it. So let's look at a hydrate problem very quickly. Almost the same as percent composition. Find the amount of water in calcium fluoride, and we'll give it away, tetrahydrate. Notice we use the prefix for 4 to name it. So calcium fluoride tetrahydrate. We'll write that in a minute as well. So just like the last one, we'll go ahead and get the total mass on the bottom. We're going to say 40 plus 2 times 19. Now watch carefully, this next part's tricky. We're going to add, even though it says multiply here, we're going to add 4 times 18. And kids are always asking, whoa, where'd 18 come from? Well, it's going to be 2 times 1 plus 16. That's very, very common, and a lot of people just accidentally memorize that water's molar mass is 18. So when you do the math there, you're going to get 150. That's your total mass. Now, what are you looking for? Well, it says how much water. Well, how much water is up here? 4 times 18 goes on top. Again, we got to multiply it times 100 for percent. And that simply gives you 48% water. Not bad, not bad. Okay, the next two problems we're going to work something called an empirical formula. So let's look at an empirical formula problem. Write the name of an empirical formula given the following percents. So you have these percents that we're going to change a percent sign and make it grams. Remember this? Factor label, what has to go on the bottom? Grams. When you see the G, go to the PT. Periodic table, and that gives you 23 grams per 1 mole. And that number will be simply, do the math real quick, you should get 1.41. 2 decimal places would be good, and that's moles of Na. We're going to do that exact same thing for sulfur. Change the percent sign to grams. We're going to say 32 grams is 1 mole. And again, with all the rounding here, 32 is good enough. So we're going to make this number 0.703. We had 3 sig figs here. I'm going to put 3 there, just to have it. Moles of S. Lastly, what do we do again? Change that to grams. 16 grams. That came from the periodic table. 1 mole. And that number would give me 2.82 moles of O. What always happens on the basketball court when you have someone maybe smaller than you guarding you? They always get picked on. You always pick on the small guy. So which one here is the small guy? Well, it's the smallest number. It's 0.703. We're going to divide every single number by 0.703 by picking on the small guy. Some of you may just instantly look at that and say, oh, 14 divided by 7 would just give you 2. 0.7 divided by 0.7 is 1. 2.82 divided by 0.703 gives you 4. Now, what do you do with these brand new numbers? You got a number of 2, 1, and 4. That tells you your formula. You're going to have 2 NAs, 1 S, and 4 oxygens. Now you hopefully can say the name of that formula, which is nothing more than sodium sulfate. I hope you heard say my name playing in the background there. The last type of problem we're going to work this week is molecular formula. Write the molecular formula given the empirical formula. So what we just calculated, we just solved for. So we've got the formula here, the empirical formula, and now you have the molar mass. Watch how easy this is going to be to calculate. All we're going to do is find the total mass, molar mass of the empirical formula. So it's going to be 3 times 12 plus 7 times 1 plus 2 times 14. That's all you do. And you're going to get a number there when you divide that out of 6. So you got 426 divided by this number, which if you add that up, I think you get 71. So 426 over 71 equals 6. Now, the question always comes to this point, what do I do with that 6? You're going to distribute it. So you're going to say 6 times 3 to get C18. 6 times 7, whoa, this is going to be a big number here, H42. And then 6 times 2 is simply 12. You're not going to be able to name that, but that is your final molecular formula. I hope you enjoy. You only have 10 problems to work on your own. If you need more assistance, I'll link in Miss Estridge's very detailed notes. Have a great week and a happy Easter. Bye.